This is part of this. Let's do a marker. All right, so continuing working on this, let's make the rocket launch slower. So we have gravity, which is 0.5. If I keep this the same, then I want to go find the physics engine. So here's the rocket update. Okay, so as long as it has this fuel, upward movement force is, I have negative 1.5. I wonder if I put this like to negative 1.0. How will that affect it? It is definitely slower. So let's do like negative 0.7 and give it like a lot more fuel, like 100 units of fuel. And then it should be able to stay in the air for a long time. Okay, too much. Let's do negative 0.3. I wonder if that would be enough to overcome the gravity of 0.5. No, not even close. And if I make you exactly equal to gravity, that probably won't work either. You'll just stay exactly still. Yeah, okay. So then we want you to be like 0.6, one tiny little bit more than gravity. Okay. What if I do 0.55? I just want I just want it to go up and hover. Just like a very, very slow burn, sort of like that. And if I do that, I can now give you almost like double. Like if I do that, like 0.51 with double the fuel, it's just a very slow increase in burn upwards until suddenly it stops. And I believe I can give it like 400 fuel now. But that should work. Oh, 400 is out of range for a U8. Okay. 255, I think, is the maximum that I can give. I forgot that it was a U8. All right, so I think that works. We see this cap sort of like come off like that, and that's fine. What I want for this this next stage is the flag to turn the flame off. So turning the flame off. Right now we have, do we have a separate render? So we have a graph node, we have a full render. Oh, right, because we could have a flag. So we have a rocket engine update, physics component. We have this graph node, but we don't necessarily have, like we're using an update for Boxstein update, this mesh. I think maybe a flag in graph node for like is active, or like draw. So I wouldn't put that there, I would put this here. So like should render, and this could be a Boolean. Should render, I suppose. I suppose I can make should render be true to begin with. That being said, we also have the ability to have the mesh be an option, meaning that as soon as it's done, I could just take away the mesh and that just works on its own. So I don't have to do this at all. What I want is when the engine runs out, I want to turn off the engine, just Just make it no longer have a any kind of mesh, and that will make that engine disappear. Now, if I want it to come back on, I have to re-add the mesh in, and that might be fine, like to sort of like store the mesh somewhere else and like put it in, take it off, put it in. In this case, it would be pretty simple of just like, hey, it's now a none. So here's the rocket engine update. The problem here, I don't have access to the fuel in the rocket engine. I have access to the transform. I have access to the rocket engine's children. So I need to know, hey, as soon as we run out of fuel, I'm done. And to me, I wonder if that, I could either put the, if I put the parent in here, I could then move the parent, but what if it's the child, parent, parent, parent? Yeah, that doesn't seem to be a way to go. I could do a messaging system, so I can like send a message to the rocket engine. Hey, we've run out of fuel. Like there's an event, run out of fuel. And that might be good. How would we store those? Inside of these graph nodes, I could hold the messages for sending a message and receiving a message. Of course, some of them won't need to send and some of them won't need to receive, so I might have to make that an option. Let me experiment with that a little bit. So one way to do sending of the messages is to use standard sync. What is it? It's is it thread or is it standard thread? Oh, where's the messages stuff? Specifically channels. I need channels. And I forgot exactly where they are in the standard library. Maybe it is in sync? Not channel. All right, let's just go take a look at, oh, I don't have browser open. Kivo69, good morning. You're enjoying the level of focus. Awesome. Let's go to Rustlang. I always forget. You have to go to learn first, and then it can come down here to the standard library. And then in here, we can look at channel. Okay, I was close. Standard sync MPSC channel. So MPSC channel. I then run channel and I get a sender and a receiver. That's what it is. Okay. And specifically, I'm going to then use try receive. That's what I'm going to use. So channel. When I create the new game state, I could create these channels, as it were. So let equals channel like that. And I think that's all I need to create this tuple that has a sender and a receiver in it. So we know that the engine, like the rocket, is going to send the message, and then the engine is going to receive the message. And so specifically, this is going to be the out of fuel, or the shut off engine. And it could be like more. I could even do like engine events where I like shut off, then turn back on, and then this could be like a channel between the rocket body and like the full rocket as a full entity, and then the engine itself. Or I could just do this as this is the event. So this could be send out of fuel, and then receive out of fuel. And what's wrong with you? Type annotations needed. Okay, so what am I gonna be sending here? I'm gonna be sending nothing. I don't need to send anything. Just by receiving a message with nothing in it, I know that we're now out of fuel. If I was doing something where I was like, and I guess that's the idea of channels, is there can only be one receiver. So I can't like just send this to everyone and have everyone receive like at once. That would be a more of an observer pattern than like a channel sending pattern, a message passing pattern. So if I did this, I now need to pass in the sender, like the sender and receiver, into the scene, like each of these nodes, and store them in. So how could I do that? Inside of here, we would want like a sender. I definitely want this to be an option because I don't know if I'm gonna have it. And you're gonna be a denser sender. Oh, I need to use it. Use standard sync sender. And a receiver. Okay. So sender. But you need a type annotation, don't you? Wrong number of type arguments. Expected 1, found 0. Can I just say that all of my messages will be like this? Oh, I can. Okay. So if I, regardless of what, like, if I wanted to have like a multiple different ones and actually pass data through it, I could probably use an enum and wrap all of my options through it. So then I'll have a receiver. So I'm gonna actually change this to an event sender because I need this to be like a very generic here. So an event receiver. And you're also an option receiver that receives nothing. Then in here, we're gonna store this in here. So we're gonna take it in here. So this is gonna be the event sender, which is an option of a sender of that. And then we're also gonna take in an event receiver, which is an option receiver like that. And then we're going to pass that straight onto here. So event receiver, event sender. I did that backwards. That might bother some people. I'll reverse it. Okay, so once I have that, now in here I can actually pass these into it. So who cares about this? The cap. The cap right now doesn't need to receive or send anything. So we're going to get none and none. The rocket engine needs to receive that it's being turned off. So we're going to get a none for a sender and a sum. And this is going to be a receive out of fuel. Then we have the rocket body, which gets a some send out of fuel, and then a none, because it doesn't need to receive anything. And then finally the scene graph, which doesn't get anything. None of the events. All right, so now the only problem is that we're not doing anything with this. Let's go down to the rocket body. As soon as we run out of engine here, so here's our update. Wait, no, this is the rocket update. Okay, so as long as we have fuel, we use this fuel. Okay, else release the okay, so we've run out of fuel now. The first thing we want to do here is we want to send that message that we're now out of fuel. Now, if possible, I'd love to only send this message once. So if self.fuel like we could have tracking fuel. I could have a flag for like we sent the message. I could also do something a little bit tricky. I don't know if this is a good idea. We also want this to this happens once. This might be fine to just send a message multiple times and then just doesn't matter. I don't know what the implications for performance with this is. I probably don't actually want to send a message more than once. If I'm sending every single frame and it doesn't matter anymore, I could be using memory and CPU that I don't need to use. I could use it somewhere else in the game. For one rocket, not really a big problem. If I add 500 rockets, maybe it becomes a problem. But the idea here is I can now say that I want... we're gonna have to have our message is here. Our event is here in the graph node. We need now to send these. Into the updates. So that way I can now see, oh, hey, I now have it. And I can actually use it at this point in time. I wonder if I should store these as a tuple. Just because they're paired together, it would be nice to like have them, because I need to pass it down as a single variable anyways. Do I? If something needs multiple events, I would have to change the way this works as well. Yeah. So if I don't change anything else, let's pass this in. Under mesh. So here's a rocket update. In here, I need to take in the send and receive. Is that true? For this specific, I want to set the mesh to be nothing, and that's stored in the graph node, meaning I'm gonna have to pass in the mesh too into update if I want the update to be the one that handles, like, to do this. That shouldn't be, the physics shouldn't be updating the mesh, or should it? We have update here. Where's up? Okay, so we have rocket update. Okay, update can do it. We can have update do it. That makes, I think this makes a little bit more sense. So I want you to send a message when you run out of fuel to send this message, we need access to the send message in here. We're doing dyn update, meaning that we need to go find our trait, update, and we need to add in the sending and the receiving. So it's going to be a send message. Well, that's fun. Send message. This works as long as I only have one message to send, right? Because I don't know what message this is at this point in time. I only know what it was at like the top level. If I want to send a message and have potentially multiple entities receive it, I don't think that channels is going to work, right? Because creates a new asynchronous channel returning a sender receiver halves. Only one receiver is supported. If the receiver is disconnected while trying to send, okay, that's not a problem. But this is the problem that we have here. Only one receiver can be supported, meaning that I can talk directly to the engine, but like if I want this to be very generic, I need a completely different system. I don't want to create something global-like, but I wonder if it would be like necessary for me to do that, something like that, where I could create that sort of like observer pattern, centralized event handling system. What do I mean by that? What if I were to create like a struct event, like the event system? And in this event system, I want to have all of my different types of, I want to have my observers. So this would be, I had to have observers, which would be a vec of something that like implements observer. Which would be that update method. Like the update could also, it's like the update struct could also implement observer. With it, this would probably have to be a box dyn observer, wouldn't it? Have to be a box, yeah, a box dyn observer. If I do that, that's pretty much the only thing I need to care about here. I don't know if I want to like attach the traits into the event system to like, that might be a little bit weird. We would probably have like an enum events, something like this. And then one of the events would be like sent out of fuel or something like that. Ran out of, or engine off. Like we could have engine off, something like that. And then if we turn the engine back on again, we could potentially have an engine on. Okay, so we have the observers like this. We would implement on the event system. I just like to do new all the time. It's just, I don't know. I like the constructor style of doing this. I'm not necessarily gonna like implement anything with this. It's just gonna be a new event system. observers is going to be an empty vector. And of course, you're upset because we don't have this trait observer, so we would need to implement that too. So trait observer right now doesn't have anything in it. Vito Renis Duarte. Oh my gosh, I don't even think I came close to pronouncing that. I'm so sorry. Hey, both Tokyo and Crossbeam have MPMC channels. You know, I haven't worked with Tokyo very much. Does Tokyo have the ability to send a channel? Like, is it really a channel where multiple things can receive? I think that's the problem that I would have is I think it's just a problem with how channels work in general, right? Because I want to be able to send to multiple listeners, like multiple observers. Maybe listeners would be better, but I'll keep it observers right now. That would work. They could do that. I could have one entity. So like what I want here, I want my physics, my rocket update here. When it runs out of fuel, I want it to emit a message to, you know, whatever, like on a channel or some kind of like event system, maybe the thing that I was creating. I want that to then send out eventually, essentially like an event. It could be an enum of those events, for example, that says, hey, we're out of fuel. I then want n number of other entities. So in this case, right now, it's just the rocket engine. I want you to receive that we're out of fuel, and then update the mesh to like be a none now, and that turns off the mesh. And then if I send, you know, hey, we have fuel again, like we refueled and we're on, we're now like, you know, okay, we turned off the fuel. So can I do that with Tokyo and Crossbeam? Well, I guess I could do that right now with what I have. But then let's say I want another message, but I want the same channel system passed into all the nodes. If that works, I would prefer to use that. So what is it? It wouldn't be here. Let's go to crates. Let's take a look at Tokyo first. So I've used Tokyo, but only as a consumer, just sort of like being forced to use it because of some crates that I've used in the past. I've not really ever dug deep into it. I haven't read the book. Let's see, channel. So MPMC, so is that unbounded? Hold on, what do we got here? Is the broadcast one. Broadcast, okay. This is supported on features sync only. Create a bounded multi-producer, multi-consumer channel where each sent value is broadcasted to all active receivers. All data sent on sender will become available on every active receiver in the same order as it was sent. The sender can be cloned to send to the same channel for multiple points. Do I have to use threads with this though? That's the next question. I've been not using threads so far. My game has been single threaded, or this visualization. It's not really a game. It's single threaded. So what I have to do, let's see, RX2 subscribe. So I create a broadcast channel, and then is 6. So send, receive. Huh, receive is mutable. Broadcast and channel 16. Let mute RX2 equals TX subscribe. Okay. Get RX1 receive, RX1 receive. Okay, so we're gonna receive 10 and 20. Then RX2 receive, RX2 receive 10 and 20. Sup Kevo, no problem. It's okay. Don't worry about that. I hope that you know things are going well though. And then transaction. Okay, so the one transaction we send 10 and we get 10 twice, and then we send 20 and we get 20 twice. So it looks like we have RX1 that comes out of this broadcast channel, and then we have RX2 that's subscribing to transaction. The crossbeam one is one you can use without Tokyo's runtime. All right, we'll take a look at that next. So that's a way to send it, and I think with a lot of these you can use a try receive, because these are blocking until it sends. So I think I could do a try receive, and I get an option of, hey, it's none if like there was nothing sent, and it's something if something was sent. And this might work. And then you're suggesting there's also crossbeam. Like Tokyo seems to like almost own this market, so I'm looking forward to like seeing more of these. Okay, so more of these like other choices. All right, so I see channel in a couple different places there, but let's see here. So we have crossbeam channel, receiver same channel, and then sender same channel. Huh, that's not exactly what I was expecting. Let's go to here. Multi-producer, multi-consumer channels for message passing. It's Signalized. Good morning. Am I still learning programming patterns? I am. Right now, I am learning how to attach different entities to each other. So I have like an engine attached to a rocket body, and I want to turn off the engine when we run out of fuel. But because they're different components and one is nested inside of the other, I need to figure out a way to send a message to that rocket engine. And the book doesn't even come close to talking about that. It's like, you can figure that out, or you can just go find another tutorial somewhere else. Okay, so we have this crossbeam channel unbounded. This creates an alternative to standard sync MPSC with more features and better performance. Okay, nice. Create a channel of unbounded capacity. Okay, so send and receive equals unbounded off of crossbeam channel. We can send anything in there. So for example, a static string or a static stir. And we receive the message. Okay, well that's pretty standard. So I can hold 5 messages at the same time. Let's see. creating an okay, so I could get an unbounded channel. A special case is zero capacity channel, which cannot hold any messages. Instead, send and receive operations must appear at the same time in order to pair up and pass the message over. That might work with mine. What happens after I learn programming patterns? Yeah, I'm planning on making a runner game. And I already made one before I started learning these patterns. Basically, a very naive approach. But now that I have these, it's going to be a very interesting sort of like what I can do afterwards. I'm not planning on making a huge game. I don't want it to take like a year for me to make that. Okay, so setting blocks until receive operations appears on the other side. Okay, I don't want to do that. Sharing channels. Senders and receivers can be cloned and sent to other threads. What if I don't want to send to a thread? What if I want to keep it in the same thread? Note that cloning only creates a new handle to the same sending and receiving threads. It does not create separate stream messages. It's also possible to share senders and receivers by reference. Okay, disconnection, blocking operations. There's try receive. Okay, so try receiving a message. I think that's... because that won't block then. Why did I choose Rust for game dev? It's more of I chose Rust for dev, and also I feel that game dev is a really fun way to learn Rust. Also, I do business applications during the day, so game dev at like in the evening, even if I'm not like planning on making anything that I can sell, is like perfect anti-burnout system like for me. If there are no threads, channels are probably not needed. How would I get the messages over? Can I like... what's the alternative to channels then? For sending a message? An example, receiving a message from two channels. Actually, I wonder, do I have... I don't have the example of it that I like wrote last time. Okay, so if I do those, any number of them can receive. When calling a function on the receiver side with the message as an argument work, I don't think I have access to that. So let's go through, let's take a look through here. I'm gonna fold everything. This is sort of like exploded out a little bit. It's all in one file, which is suboptimal. But here's the idea. I have these graph nodes, which are the equivalent of like a game object or an entity. My rocket body, so the entire rocket itself, is a graph node, is an instance of this graph node structure here. So it has a mesh, but it has children. It has two children. It has a cap to the rocket, and it has the engine of the rocket that are in this children. And the children are, of course, more graph nodes. So I want the rocket body, which has the engine as a child, to tell the child to remove its mesh, but only when it runs out of fuel. So I don't actually, I need to be able to tell it in some way, and I don't know at runtime, without adding like a type enum into every single thing, so I can like check, hey child, are you this type? Go ahead and, you know, turn yourself off. So I think that's what I'm having with the problem with is that I'm not doing this object-oriented style. I'm doing this much more functional style. And that's the reason why I can't just reach in and call a function, because that function needs to be there for everything. I guess, let's see. Is that true? Now that I'm saying that, now that I say that, what would happen if in this graph node, I have this pub function new that ends right here. Okay, I have render and we have run. Let's open up run and come to the end here. What if I had another function here? So pub function, like receive message, or like receive event. This is mute self, and then I have an event, which is events. I don't return anything, I just do something. So this is only receiving events, so I can now only go down. This is the problem. I can only go down. I don't know if that's a problem or not. It's signalized. You really love my enthusiasm. Good luck with my journey. Thank you so much. It's signalized. I do try to be very positive when I'm programming. It really helps with the learning, because learning can be very sort of like up and down, as you can often see. People just call you Sig. All right, I'll try to remember that you're Sig. So I think this would work for sending messages down. I can't send messages up right now. Maybe we should just handle that when it becomes a problem. Okay, hold on. Let me like undo some of the stuff we've done, and then we'll try this way. And then also I missed a message. Sup Kivo, you asked, maybe do a stream on modules next time. I still struggle a little with modules. I have worked a bunch with like modules in some of my other streams. But yeah, that's definitely something I want to add in. In fact, I'm going to add that. I have a notion here of like list of tutorials to create. So I'm going to say modules in Rust. And so that adds that in there, so I won't forget that now. It's just for my convenience, saying my name can be a mouthful. Oh yeah, absolutely. But don't worry about that. I'm fine with everything. I also know that people like to come in with like really interesting names, and then like, you know, it's the game of, can the streamer pronounce the name? Should probably relearn Rust so you can follow what I'm doing. Like, I put the tag on there for questions okay, because I am perfectly happy with explaining anything. Also, you may have joined afterwards, but I have a command here that allows you to highlight lines on my editor. So you can do bang line and then a number. So in this case, we can do like 10, and that will highlight 10. And I don't know if there's a way for you to turn off the line, turn it off right now. Line 10. Yeah, that doesn't turn it off. So I have to come in here and manually turn them off myself. Remove. But you can do that if you put in a message after the line number. It then shows up when I mouse over it, so I can see. But it's a great way to say, hey, what's going on here? Or you're doing something wrong, fix it. It works in both ways. Okay, so let's reset ourselves. In fact, in a way, I kind of want to reset myself back to the beginning of the day. Let's open up Git Kraken. Line 123, what exactly is a graph node? Okay, so this graph node here, I'm pulling the name of this off of the book that I'm using, and I might as well show off this book. It is Game Programming Patterns by Robert Nystrom. It's all the examples are written in C++, so very object-oriented. in general, although it gets more and more functional as the book goes on, I've noticed. The graph node is really part of this two system where I can have this transform, which allows me to attach objects to each other. So if I run my, well, I have 13 errors. I can't run my code. I have a rocket, and then I have this engine on the rocket. And so the engine is sitting there. I'm not telling the engine to move. I tell the rocket to move, and the engine goes with it. And that's what this is I have children, which are graph nodes. I'm thinking that when I make the game, I'm not going to call it graph node. I'm going to probably call it like game object, which I think is a little bit more with my mental model of what it is. So that's what's going on with it. I hope that answered your question. I'm going to go ahead and remove that highlight. Let's see. Maybe queue messages inside or the agents, then get all the messages you need to redistribute from each node using the signal function, get messages or something. Is that for like also passing them upwards? Maybe. You've heard of the book. Is it good? You use C# and Unity. I think it's very good. Even if you're using a framework like C# or Unity, there's a lot of good lessons to learn inside of there. If you're creating your own, engine, then it's also good. It's sort of an in-between pattern. So I want to come back here, and what did I change here? So we added the channels. We added all this channel information that we're passing back and forth. So I want to reset this. So I'm going to trash all my changes. Back to the code here. I'm gonna not save and reopen main.rs. Nope, reopen live.rs. Okay. You want to buy the hard copy, you can't read the PDFs. Oh yeah, what I really like about this book is that it's if you don't want to pay, if you want to just try it out, it's free on the web. And that, or you could pay him money, which I think is really nice. So let's come here. So game states, transform, graph node. Okay, so here's our graph node. We have a render and we have a run at the end here. We're now going to do a send message. So the first thing we're going to do is sending a message. So pub function send message. I'm going to do as self. Actually, this is receive message, isn't it? Oh, weird. This is going to be weird. I guess send message works. The child will run send message. So the parent is going to be the one who can execute this. So I'm going to do mute self and then the message, which I'll name as like the type. So we'll just do maybe this will be send event. So we're going to take the event, which is a type event, which doesn't exist yet. We'll have to do that. We're not going to return anything. And then we're going to handle what this event is here. Now, another problem with this. I can't, I need to do this at a very specific, times. So I want, for example, to send a message to the rocket, the engine. Do I need to have a very specific implementation of the graph node and like have this be a box with dyn. Or we send it to update and we also pass in the event. Like here we could have update here. So in run, we have our update. We send our children. And then I also send in the event. So here, let's go back to our trait update. So if I have an, let's just go actually implement an update enum. So enum update, and then this is going to be ran. We'll just call this engine off. Okay, so we have an enum update. Let's go to our trait update here. And we're going to say that we're going to take in an event, which is a type. What did I call this? Update events. No wonder it was so upset with me. Impl, no. Trait update to your type events. Now, what this means is everything that implements this trait is now going to be very, very upset at me. So I need to implement update for scene. Let's see. Okay, actually, I want to do this. Multi-cursor for the win here. So grab you. All of you should be just part of this implement update. Go to the end, new line, event, events. Okay, so you're an instance, like you're just one of the events that we're passing in. Oh, and then I want none. Like there's a possibility that there's no event. I'll call this nothing so it's not confusing with actual none, which is a thing. Now, for our update, so struct rocket update. Where's our engine update? Okay, so our rocket engine update takes in these events. If let events engine off equals event. Okay, so if we receive the engine off event, I want to now turn off our the mesh for this. Well, next problem. I need access to the mesh. I don't have access to the mesh here because I'm a child. Like I'm a module inside of the graph node. I'm right in here, and I need to update this. And I'm running in run. I'm just doing self.update and passing all these things in here. Good morning, Chantilly. Also, Sig, I agree that I'm probably going to like buy the book eventually. I did talk with him and asked him if I could like read the book out loud. But I've been getting a lot out of this, so I'm definitely going to buy it, like a hard copy of the book, or at least a digital version of it. What? So Sup Cavo, maybe message queue inside the agents, they get all the messages you need to redistribute from each node using the signal function. So that would be like complicating run here, right? So I can say, hey, update Or in graph node, or was this what you're talking about? In graph node, we have like messages. Hold on, let me. Oh, are you thinking like something like this? Where I have like a vec of events? And it's events for this specific frame. And then we have to reset the events like every frame. Like when we get it, we pop it out. Ooh, okay, so if there's something in vec, we pop it out. And if there's nothing in vec, then it doesn't matter, we're done. Still doesn't I don't know if that helps us too much. Like if I create here events and empty vec, I know that makes you happy, but I could pass the events in to like the update function, for example, like a reference to that array, and they can push on the events. Like we have a new event here, push on this event. So what would that be? In our trait update, instead of this events like this, we'll do events. We're gonna do events, which is a mutable reference to a vector of events. Then in our rocket update, here we have these events. When we run out of fuel, we push into the events. So it's going to be events.push events engine off. Okay, so that pushes the events onto it. Now we have that in like this parent graph node. In update, we have to now do a mutable reference to self.events. So that makes you happy there. We have 2 errors. Cannot find value event in the scope. Right, okay, so here we were here in the middle of running this. So let's reset ourselves really quickly. No errors. I want the ability to check the event, turn off the mesh, but only for Rocket Engine. And that's it. That's all I care about. We have the mesh here. Do I have to patch the mesh in too? And have that be updated and changed by update? I think we're gonna have to. I don't really see a way around this. So in update, we're also gonna have to pass in the mesh, which is a mutable reference to an option mesh. So here we are in a Rocket Engine update. Let's pop off an event. So we'll loop through each of the event. We'll loop through all the events in here. So for event in events. So here are this. It's a Yeah, okay. Does this really need to be... Oh, it does, because I might need to like add on to it. But I don't care about that. I'm just reading it right now. So I'm looking at the event, and then for each of those, if it's the one I care about. So if it's that rocket engine off. So if let events engine off equals event. Okay, so if it's the engine off, then I want to say mesh. I want to reassign mesh to be a none. Core option this. Expected mutable reference found in enum option. Wait, can I not assign mesh to be none? Do I have to dereference this? It's like, oh, I do. I have to dereference it to get at like the specific place in memory. But 3 errors. Okay, so expected 5 arguments, got 4. Okay, so then run. We also want to send in a mutable reference to self.mesh, like that. No errors. Let's see if this works. So if I run this, does the engine turn off when it falls? No, it did not. The red engine still stayed on there. So what happened here? Graph node. Okay, we have a rocket update. We don't really care about this mesh here. Or the transform. Okay, so we're pushing into the events. When we run out of fuel, so we become 0 fuel, we push the into events engine off. So now events on the parent node for the rocket update has the engine off. You know, maybe am I getting the same events? Is that a problem? So which events is this? When we create our graph node, okay, we're saying that we're gonna have this events vector here. Okay, so we implement the graph node and we create this as an event, a vector of events. I foresee this being a problem here. We run. Okay, then we go run. We send the self events into update. I think this is the problem. It's I'm sending the rocket body is getting the event that the engine is off, but we're not sending the other events. Like that event is never making its way to its children. I need to do something like in child.run, send the events in there. What if I make the events not even part of this at all? Like what if I let's change this around. Let's not store events in the graph node. So we don't have you here. Render, we don't care about you. Run, we're not doing those anymore. But an update, I think we still need the events coming into update. Which means that in run, we need events being passed in. So events is a mutable reference to a vector of an events. So I do need this. So I need events like that. And then in run, children, I just pass this along and I hand in the events down here. In our update now, we need to pass in run to like the parent. So instead of events being as part of the graph scene, we're going to make events part of the game struct here. So events is going to be a vector of events. In update, we're going to pass in a mutable reference to self.events like that. And that goes all the way through everything. We need events, which is an empty vec. No errors. Let's see. Did I miss anything in chat? Chantilly, you've been doing a lot of drops and you've covered that target. That's pretty awesome. Cowtel, good morning. You put so much effort into making an event emitter in Rust. You did? And like, what did you use, like Tokyo or like a channel system? Did you like create, like roll your own? What did you end up using? Okay, so if I do nothing else, I know it's, I don't think it's ready to use yet, but let's try it and see what happens. The engine turned off. Okay, I don't know if that was very visible there. The engine was on and then it turned off. Okay. Could you see that? Was it too small? That worked though. At the end of it, I want to reset. At the end of every frame, I want all the events to be gone. Is that correct? I don't know. I don't know if that I want to do that. The problem is if I keep the event in there, it's going to continue to like execute that, remove the mesh code. So I kind of want to remove it as soon as I use the event. That of course means only one thing is listening for it. And the order that like I send things down the stack of like game objects or the graph nodes is really important, because if I have something like that's a child nested down here and it sends an event, but something up here is the one that wants to receive it, if I at the end of my game loop say, you know what, time to reset all these events, that's a problem. I like almost need to like, has everything listened to it? Like, has everything got a chance to watch it? For right now, I could say, maybe I could mutate this vector and just say like, hey, when you receive the event, go ahead and remove it from, like, it's been listened to. And like you can remove it from the vector here. So we have the rocket update, rocket engine update here. I can do this to make those happy. Okay, so I want to almost enumerate this through this. So in dot iter dot enumerate, and that gives me for event. So this is going to be the index and then the event. Attempted. Oh, this is a method. And then in my index, so I set that mesh to be none. I really want to remove this from the array, but I don't know if I don't think it's a good idea for me to do this in the middle of the looping through the array. That seems like a terrible idea. So instead, I'm gonna want to let index to remove equals almost like a none. So like it's a none. And then if I find this, if we loop through, I want index to remove to be a sum of index. It seems not the best. After our for loop, then we can say if let sum index equals index to remove. Then remove this from that events vector. So events dot, is there a splice? Creates a splicing iterator that replaces the specified range in the vector with the given replace with iterator and yields. Oh, is there a remove at? Removes the first instance of item from the vector if the item exists. Okay. Okay, removes and returns the element of position index within the vector, shifting all elements. Okay, so I want remove, and then this is going to be the index. Do you return an option or something? No, you just do that. That's cool. So that removes it out of the vector, so we won't just grow forever. And I kind of want this to run once. We can do a print line, which is turning engine off. Sort of like a logging statement here. And let's go ahead and run this. I think it's going to run many, many, many times. But it's not for the same reasons. Okay, hold on. Let me catch up with chat again. Cowtail, you did your own thing. You created a struct with a hash map and used reference strings. Oh, you used lifetimes. Strings is key to function pointers. Had to pass it a global state struct to make it work so it can mutate the global state from within the closure because of the move. Oh, you found a bug. Oh no. Maybe you need a ref cell or something now. I did. Where was it? So I don't know if this will help you. I did a, let's see, dev.to article. I don't know if it'll find mine. Yeah, I did this observer pattern in Rust article on here that talks about how to create like an observer pattern in Rust. I used arc mutex, but I think you can still use RC. I think you can use RC also with it too. I don't know if this will help you. So you could take a look at it. It might also like inspire you to do this, to like sort of work with that. RC is probably what you need in this case. It's all single threaded. Yeah. Arc is one of those things where you can say like, hey, I don't know which one I use. Like, it might be multi-threaded, it might be single-threaded. Whatever. Arc and RC work the same if it's single-threaded. Our Arc works also in multi-threaded environments. I don't know if there's a performance problem if you use Arc in a non-multi-threaded scenario. All right, so I want to now in updates for the rocket. Okay, I'm running this every single time, which means we're also doing this. We're launching off that child. Well, okay, I see this here. Launchable. Like we're using a graph here. We're saying like, hey, launch it. Also, are you launchable still? If not, like launch it multiple times. What if I use the fuel as like my little state here? I have enough fuel. We're moving upwards. Just apply the force. We're going upwards. When we hit 0 fuel, so if I do something like this, else if self.fuel is exactly equal to 0. So if we run into 0 fuel, then do these two things. And then finally, actually, we have this fuel. I can use a state in here. We can have like should engine turning engine off. I don't know. Let's see. When we run exactly out of fuel and it becomes 0, then we push the engine off. So we push this event in here. We also tell the child, hey, if you're launchable, go. And then self.fuel minus equals to 1. And now finally we have this else. And the else is basically we're doing nothing at this point. There's nothing for us to do. Is that true? I think it is. We don't have any upward momentum force. We're just being affected by gravity at this point in time. So if I run you, now I expect our turning engine off to only run once. Or us to have a horrible error. All right, thread main panicked and attempt to subtract with overflow. So I have this else if in here. It ends there. Self.fuel minus equals 1. It's an else if. Exactly. Oh, because it's a U8. Oh, I forgot. I can't do a minus 1 when I'm at 0. We are going to need to store some kind of internal state in here. So is so like did we like send that event like that event? So did like did or send events? I don't know if we want to do send events or if it's going to be did like ran out of fuel. Maybe did run out of fuel. And we have this be false to begin with. We create this new one. Did run out of fuel. Sorry, you are a Boolean. And you are false. Okay, now inside of here. We're going to put you back. You just become an else. All right, so else. What are you upset about? Failed to resolve use of undeclared type or module events. What? What's wrong? Update. Everything is wrong. It's very upset at me. Can I find events in his scope? Did I like delete events somehow? Or is it because like one error is causing everything else to error and therefore it doesn't know what's going on? Here's this event. Enum is not supported in traits. Oh no. I have a problem with brackets, else you are there, but you shouldn't be. There you go. There's a bracket problem. Bracket problem. Okay, so else inside of here, we only want to do these things if these things. This is true. So else if, okay, self.fuel is equal to 0 and self dot did run out of fuel is false. So not this. As soon as we did do this, now we're out of fuel. We send these events, and at the end of this, self dot did run out of fuel equals true. Now let's try it again. Turning engine off, that message only sends one time. We also only send that cap up one time, which should be fine. At that point, we don't even need this is launchable anymore. Because like this child physics launchable, let's go find launchable. So that's our physics update. So let's go find physics. So we have our physics component here. Launchable is a Boolean. Oh, we need launchable. Okay, we do need launchable. Yeah, never mind. I think we're fine then. Okay, so we're only launching you once. Oh, we're setting launchable to be false, which I guess is true again. Now, it's no longer launchable because it's been launched. Okay, so one problem down. We have the engines now turn off properly, and we can see this again running here. The engines turn off, and we only send that message once. Excellent. Let's see. Catching up with chat. Yeah, RC is probably what you need in this case. It's all single-threaded. You think you need a wrap global state and an RC, and it'll be good. It just needs to share multiple mutable states for the emitting of the events. Okay. Yeah, that probably will work. Now, global states can be like really dangerous. Like it's really hard to like debug problems that happen in there. I think you're doing something Rust dislikes. You feel it's in your heart. It's safe though. That is such a common thing in Rust. It's like, hey, biochecker, I know what I'm doing, and biochecker's like, yeah. No, I don't like it. Like I don't care that you know it will never be a problem. I don't like it. Figure out a better way to do it. Now that doesn't mean that it's bad. It just means that you have to now figure out a way to tell the borrow checker that you know what you're doing. All right. What is next here? I want to send this code on up. So we are turning off the engine. Turning off the engine when running out of fuel. Push that up. Okay, this has all been me procrastinating from the real hard part, which the next thing that I want to do is I want to remove the cap from the I need to remove the cap from the rocket and then make it a child of the scene so that it can properly fall on its own. Now, right now we're doing that, but maybe through some trickery. So we launch it. We apply the physics to the gravity, and then we set the child to be affected with gravity true. Okay, that's fine there. And then we do is launchable, but here's the thing. I need to remove the child from here and give it ownership, like put it as a child of the scene, so that it's in the same level essentially as the rocket. Now, how would I end up doing that? Removing it from the list of children isn't that hard. I can do the same thing that I'm doing. I can grab the index in here by doing like the iter and enumerate. That will give me the index of the child that I want to remove. So let's like maybe do this here. So let this will have to be mutable. So let mute index of child to remove. And we're going to set this to be a none. So we'll make this into an iter dot enumerate. And that will give us an index and the child. And then we're going to say index of child to remove equals a sum of index. Okay. Now you're upset here. Oh, cannot borrow. Oh, iter. Can I use iter mute? I can. Okay, so now our index of child to remove, I want to then remove this out of here. So let sort of like the child like component equals self dot, actually it's just children dot remove, and this is going to be, oh, this has to be a if let sum. So hold on, let's do this. If let sum index equals index of child to remove. Okay, now that we have this, we're going to then say let child component equals this is the children dot remove. Removes and returns the element. So I'm going to get the child out of here, and I'm going to get ownership of it, which is, you know, that's kind of what we want. So index. This is going to be a graph node. I now need to somehow get it all the way up. So the rocket body is a child of the scene graph. I now want to push it into the scene graph's children. That's where I want to get it into. How to get it there is the question. Here's our rocket update. I now have the child component. It's owned right here. I now need to give it a new owner. I have my own children, but I don't have, like, my sibling. I could hand it my sibling. Maybe that's what I do. I just say, you know what? I'm gonna, I pass in the siblings. I think that's what I can do here. So in my trait, let's add in another thing here. Wait, does this... Did I get everything? Oh, it worked. Okay, cool. All right, so at the end of here, am I multi-cursoring properly? I am. Perfect. So we're going to have the siblings, which is going to be a mutable reference to a vector of graph nodes. I'm worried about this working. I don't know if it's going to work. Now, when we run update, we're going to have to hand it the parent, the parent's children. Is that correct? Let me think about this. So we have our graph node. It has the children. So we have the scene, and then underneath the scene we have the children. So right now there's just rocket. I want to, and then rocket below that has the cap and the engine. I want to take the cap, move it from down here to up here. For sibling along the first one, where you have scene, there are no siblings for scene. Scene, like, it just, there aren't any. So that's a problem right there. I can't pass it. That's a problem. I wonder if I can, like, pass it upwards. I don't know. Let me procrastinate by reading chat. Let's see, Cowtail. The thing is, you're implementing a JavaScript like event emitter in Rust, so the ease of using a callback in JavaScript to update global state means it's extra complicated to do in Rust. It's so comfortable to have callbacks hide all their internal workings before being triggered, and then having the callbacks do whatever to the global state. You got it working and not working. The good news is that it's bad news. Oh no! That sounds terrible. It works so long as each time you emit an event, you need to clone the global state before passing it to the closure. No! So it works, but you're not comfy feeling looking. Yeah, because also, if you're cloning the global state, there's not one global state anymore. You can't trust it, right? Because you might update one of them, and then the other one won't update. So it's an archmutex, so it goes change the global state. Wait, are you cloning the archmutex, or are you cloning the actual global state? Because cloning the archmutex or the RC mutex is not a problem. Like, okay, cloning arc, you still only have one state. You're just cloning essentially like wrappers that point to the state and like hold it in memory. That's fine. That's okay. That should be great. You're good there. Yeah, it works, but it's uncomfortable to have to clone each time you call the emit. The clone is practically free if it helps. Yeah, I think that's fine. Now with this, How do I want to do anything like this? Well, you know what? I've been streaming for almost 2 hours. Hour and 45 minutes. Hour and a half, I guess. I'm thinking I might want to take like a quick break. Go grab some water because I ran out of tea. I wonder if we can hide the clone away another function so the user never needs to clone. I don't know. I hadn't thought about doing that before. Sort of like trying to make it nice for the user. Maybe. Okay, well, with that, I'm going to take a quick break. What that means is I'm going to put in a marker here for the upload to YouTube. This will be a break, so there'll be